Hello students, I hope all of you are doing perfectly well. In today's lecture, we're going to be talking about the expectation value of an operator. So let's just see what are the formulas of that. The expectation value of a dynamical variable, the expectation value of a dynamical variable or an observable of an observable A at time t is given by expectation of A at time t is equals to summation over n, where n is the total number of where n is the summation over all the eigen values of A. Probability of getting the eigenvalue of an at time t into an. That's all. Where we know that E cap phi n equals to an phi n, where n is equals to 1, 2, 3 dot 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 capital N for n-dimensional Hilbert space. For n-dimensional Hilbert space. Of course, it will have n number of eigenvalues, eigenvectors, all are linearly independent. For n-dimensional Hilbert space, I can just write it like this. So, probability of getting the eigenvalue an can be written as, or at time, just say at time t equal to t0 and not t. It will rather be better at time t0. Is at time t0, probability of getting at time t0 into this. So this can be written as summation over n. Probability of getting n at time t equal to t0 is phi n psi of t0 into an into psi of t0 psi of t0. Well, there is one more thing which is very, very important. See, this is a constant quantity, huh? You don't have to worry about that. It's a constant quantity. So, on the next line, I can write, so the summation over n does not affect anyhow upon this quantity. I can do one thing. Just because we know that n should be real because A is a Hermitian operator. Can I just write it down like this way? Summation over n phi n A cap psi of t0 psi of t0 psi of t0. Can I do this? Can I do this? Well, I think I can, because you see, and this has to be a mod square actually. Okay, this thing probability is always with a mod square. I was wondering, there must be something. There has to be a mod square. Now there is an an. There is an an. This an should come from, so if there is a mod square, there should be a, okay, it can be written as this. I can just do it by my way. A cap operates on phi n, gives me an phi n. This is actually phi n psi of t0 star phi n psi of t0. Phi n psi of t0 star is psi of t0 phi n. So I can write it as psi of t0 phi n psi of t0 into an divided by psi of t0 psi of t0. Right. There I can tell. Okay. Now I can just very well write it down. This an, just bring it inside it. So I can write it down as summation over n psi of t0 phi n a cap psi of t0, or let me just tell you, a cap t0 a cap phi n psi of t0, because a cap operates on phi gives you a n phi, so a n will come outside and it will be psi of t0 phi, because I know a cap operates on phi gives you a n phi. Okay, fine, I can write it like this, and then in the denominator I have psi of t0 of course. Now you see this summation psi of t0 is constant, psi of t0 is constant. You can take the summation inside and you can just write it down as like on the next page, psi of t0 a cap summation over n phi n, right, into psi of t0 divided by psi of t0 psi of t0. Now summation over n phi n is basically your I cap from the completeness condition or closure property. Completeness or closure property, that is summation over n phi n should be equals to 1, because the eigenvectors of the Hermitian operator cap forms a complete orthonormal basis of the Hilbert space, so they must satisfy the completeness condition. So of course this thing is actually equals to your I, so it is psi of t0 a cap psi of t0 divided by psi of t0 psi of t0. Now expectation value of a dynamical variable is always a real quantity, because probability is a real quantity, eigenvalue of a Hermitian operator is real quantity, an is real, and p of an at time t0 is also real because probability. Therefore expectation value of a at time t0 should be a real quantity always. This thing you should remember, because मैं ये बता दे रहा हूँ सारे बच्चों के लिए, क्योंकि आइगन वैल्यू ऑफ हर्मिटियन ऑपरेटर हमेशा रियल होता है. दूसरी बात, प्रोबेबिलिटी ऑफ गेटिंग एन आइगन वैल्यू एट टाइम t इक्वल टू t0 हमेशा रियल होता है, प्रोबेबिलिटी कैन नेवर बी इमेजिनरी. तो इसलिए एक्सपेक्टेशन वैल्यू इज ऑलवेज अ रियल क्वांटिटी, इसलिए एक्सपेक्टेशन वैल्यू हमेशा रियल होता है. दैट इज अ वेरी इंपॉर्टेंट स्टफ टू रिमेंबर. चलो इतना हो गया, तो और कुछ ज्यादा जरूरत नहीं है. सो दिस इज बेसिकली द एक्सपेक्टेशन वैल्यू ऑफ एन ऑपरेटर. दिस इज हाउ यू जस्ट डिटरमाइन द एक्सपेक्टेशन वैल्यू ऑफ एन ऑपरेटर. आइदर यू कैन यूज फॉर्मूला दिस और फॉर्मूला दिस. So I can simply write down expectation value of A at time t0 t equal to t0 can either be written as summation over n probability of getting the eigenvalue an at time t0 into an, or it can be written as psi of t0 a cap psi of t0 नीचे psi of t0 psi of t0 psi of t0 psi of t0। और अगर उस नोटेशन में वेव फंक्शन नोटेशन में लिखना है तो डेफिनेटली यू कैन राइट इट डाउन एज इंटीग्रेशन psi of r vector comma t0 star a cap psi of r vector comma t0 dq bar नीचे इंटीग्रेशन psi star of r vector comma t0 psi of r vector comma t0 dq bar. So that is how the expectation value is written in the wave function notation. Okay, I think it's done. If you have any question, to let us know in the comment section. If there is any doubt, we can always solve it for you. Okay, and we will again continue on the next section. अच्छा, ये इंटीग्रेशन ऑल स्पेस में हो रहा है, ऑल स्पेस, ऑल स्पेस। चलो, psi star of r vector comma t0 a cap psi of r vector comma t0 dq over all space, all space। चलो, थैंक यू वेरी मच, मिलते हैं नेक्स्ट सेशन में, बाय बाय।